All right, we're going to cover the last three parent functions, and probably the three you'll see the most in this unit. So the first one is the absolute value parent function. Really important that you understand absolute value means the distance from 0 on the number line. We'll talk about that more in just a second. And of course, here's the notation. It's just two vertical bars around x. So as we go over here and make our table of values for the absolute value function. So the first number we're inserting in for x as our input is -2. And if we look at really quick a number line, to think to yourself, how far is -2 actually from the number line? And you wouldn't say it's -2 units. When you're talking about distance, if you're talking about how far you are away in your car from a restaurant, you say, I'm 2 miles from that restaurant. You don't say you're -2 miles from the restaurant. So -2 has a distance of +2 from 0 on the number line. So therefore, when we input any number into the absolute value function, it's going to output a positive number. So -1 is a distance of 1 from 0 on the number line. 0 is 0 units. 1 is 1 unit from the number line, and 2 is 2 units from the number line. So those are the 5 points we're going to graph for the absolute value function. And you'll notice when you graph these points, it makes a V-shaped graph. It's really important, I'm doing this one by hand just to show you, really important that you make sure it appears to be a V-shaped graph. Because you're going to see here in a second, we're going to graph another function that is really similar into shape, but doesn't have that pointed edge at the origin there. All right, so now we do domain and range for this parent function. Domain is how far left and right it goes. So as we look at this arrow right here, the left arrow, it's going up, but it's also going to the left forever. And this graph is going up and to the right forever. So the domain is all real numbers. The range is how far up and down the graph goes. Now quickly we see that it does go up forever. Both those yellow lines are going up forever, but it doesn't go down forever. It has a lowest y coordinate. And remember, for range, we use the y's. So that lowest y coordinate is at 0. And again, we use a bracket because that means it's inclusive and it includes this value. And it goes up forever, so interval notation from 0 to infinity. And again, we're going to go more deeply into domain and range here in a couple lessons. All right, so our next function is the quadratic function's U-shaped graph. The equation you can see there's f of x equals x squared. And again, you'll notice I'm still using y equals x squared every once in a while. We're slowly going to phase that out. Remember, that's the same thing as f of x equals x squared. Don't get confused by the different notations. And here we're just squaring all the input values. And again, notice, it can be really important here a little bit, the same x values we've picked. We've picked -2, -1, 0, 1, and 2. That's going to change here in just a minute. When you square those values, make sure you put parentheses around them in the calculator if you need to, but -2 squared is 4, -1 squared is 1. If you're getting negative values for these, that means you're inserting them in the calculator without parentheses. Now graph those points. The big thing with this graph is notice it doesn't quite have a point to it like the absolute value does. It's increasing a little bit more of an exponential rate on both ends, so it's more of a U shape instead of a V shape. It's really important you distinguish between those two shapes when you're graphing these on your assignments. However, domain and range are going to be the exact same thing for the absolute value function, or as for the quadratic as it was for the absolute value. This graph is going left and right forever. So we're going to write negative infinity to positive infinity. It's going up forever, which is just indicated by these two arrows. It's going up forever, but it is not going down forever. The lowest y coordinate is right here. That y coordinate is 0. So that's how we write a range. All right, so we're going to move on to the last parent function. And this one for some people is the tricky. So the square root function, also sometimes called a radical function. In parentheses, I have there broken graph. Now, it's not really broken. It's just the way the square root function works. But it sometimes reminds students it kind of looks like it's broken because it almost looks like it gets cut off. And really it does. So we're going to take the square root of each of these values. And now you'll notice, let me mark out -3 there. You'll notice when we try to take the square root of that first x coordinate. So if we take f of -2, can we take the square root of a negative number? Remember, the square root means a number times itself gives you that number. So at least in the real number system, that's not possible. You can't take the square root of negative numbers. So this is why this graph is going to be a little bit broken. And really, we only want to graph points when we're doing this parent function that are perfect squares. So like we can take the square root of 0. Square root of 0 is 0, and the square root of 1 is 1. The square root of 2 is a really long irrational number, messed up decimal. So we could graph that, but we want to avoid really tricky decimals when we're graphing. So the table of values, the x values that we're going to pick 0, we're going to pick 1, we're going to pick 4. That's the next perfect square, and we're going to pick 9. So instead of our normal -2, -1, 0, 1, and 2, we're going to pick these 4 x values. You could keep going further, but then it gets kind of tricky to graph. Square root of 4 is 2, the square root of 9 is 3. Notice even the point 9 goes off the graph a little. You'll notice there's only one arrow on one of the ends because this graph cannot exist here on the left-hand side. So it does not keep going that direction like all of our other parent functions. So when we list the domain is how far left and right this graph goes. Well, it doesn't go. It stops going to the left right here at this x coordinate. Remember, domain, we use the x's. So that leftmost x coordinate is 0, and we're going to use a square bracket since it includes that value. And then it's moving to the right forever. It's going to keep moving right all the way to positive infinity. Range is how far up and down it goes. Again, it doesn't go down past the y coordinate of 0. This is the lowest point as well as the leftmost point. Now the question is, does this graph go up forever? And the answer is yes. Doesn't really look like it's going up, but it is just going up really, really slowly. It's going to the right really quickly, but it is going up very slowly So that's our range.